Okay, so we will continue. Again, we are still in CCUS or CCS simulation using CMG software. In previous in previous steps, we have completed the I/O control, reservoir section, component section, rock and fluid interaction, and initial conditions. And now we will move forward to the numerical section. But before that, I just want to make a big modification actually, or a big correction. Specify property. Here the top depth, the top grid should be put on this layer one. So it's not in whole grid. I just copy and then paste and then I will delete it. And the others will be put on the whole grid. Okay, so click on OK. All right. And then just, okay, so it's like this. Okay, and so far so good. If we change it to 3D view, then and rotate. Okay. And let's see if we check the other permeability in I direction and grid pay depth. Okay, okay, so it's good. All right. So I think we can move forward from here. We can go to the numerical and time step control. All right, so let's do this. All right, and maximum number of time steps this, and maximum simulation max time here is 0, but let me change it to this one. And maximum simulation date, I will use 200 years because yeah, in CO2 injection or CO2 storage, it takes very long time. It's not like production. After you inject, after the completion of the injection, you need to monitor. And yeah, or you can also do the simulation to know how the CO2 plume will migrate from the well, from the injector to yeah, to the sections of the reservoir. You need to check that. You need to check the containment, and yeah, fortunately we can do that. We can observe hundreds years and even thousands of years using simulation. So I'm going to use this, and maximum time step size DT max, let's change it to 75 days. It's actually not necessary, but yeah, it can also be increased. And DT min, minimum time step size, let's make it smaller so it will be even more detailed. Okay, and then first time step size after well change, 0.1. All right. And normal variation per time step, press, yeah, we can follow the default 1000. And saturation, normal variation per time step, let's change it to 0.05. And global composition 0.005. And aqueous component 0.3. Okay, yeah, these values are the values recommended by CMG, so let's follow their instruction. Okay, and for the temperature we can follow to 20 degrees. And or no, it's yeah, let's keep it that way. And this is okay. And maximum changes per time step, max change for pressure 20,000, and for the saturation 0.8, and for the global composition 0. Okay, 0.8 as well. And for the temperature, it can Let's increase it to 20 degrees centigrade. Okay. So far, so good. And then let's go to here, convergence tolerance. Changes tolerance for pressure. Let's change it to 1E like this. And for the relative tolerance for hydrocarbon component molar density, 0.0001. And relative tolerance for water component molar density, yeah. Density is very important in CCUS. Density is very important in CO2 storage because later on we will deal with solubility. And if you have solubility, there will be changes in density. So that's why we want to make it more detailed by reducing or by decreasing, by lowering down this relative tolerance, okay? So that we can get a more accurate computation. Okay, and for the maximum tolerance for any equations, max res 5. Okay, okay, and what else? Linear. Let's go to linear solver keywords. This one. For linear solver precision. Okay. And for the linear solver iterations, iter max, let's increase it to 200. And for linear solver orthogonalizations, north, 200. Okay. And let me check. So, all right. So let's check for, let's double check, I mean. So norm and press 1000. Okay, good. And norm and Satur 0.05. Norm and G molar 0.005. 0.005. Norm aqueous 0.3. Okay, good. And then max change press. Max change for press. Okay, 20,000. Max change for Satur 0.8. Max change for G molar 0.8. Okay, temperature, it's not very critical. All right, and then let's go down. Okay, here. So converge. Yeah, the main keyword is converge. Converge press 1E 0.05. Okay, it's in kPa. And then converge HC 0.0001. Same thing with water, converge water. Okay, and then PREC, linear solver precision PREC. Okay, 1E06. And then north, where is the keyword north there, 200, max 200, and dt mean. Let's find keyword dt mean, 1E6. Okay, and dt well, do we have dt well? Dt well, oh, this one. All right, dt well 0.1. And converge, again, converge max res, 5, e to the power of minus 05. Okay, so far so good. So that's the numerical setting that we need to apply. So click on apply and click on OK. Okay, so numerical setting already good. Very good. And then let's continue. Geomechanics, we will skip it. And as you can see, it's already okay, by the way. Okay, for now we will move to wells and recurrent. We will install or we will drill one injector. One vertical injector will be added for the injection of CO2 into the reservoir. Okay, this well will be the only well in our model. Okay, so here, wells and recurrent, click on that. And first, we will click on dates. Okay, double click. All right, so here you can see 2023, it's in the next year, or not next year, because yeah, I recorded in 2022. Yeah, so I call this next year. Okay, so add new date or add a range of dates. We will select this one because we will add a range of dates. So from 2023 to 2223. So it will take 200 years. Okay, so days since simulation start is 73,048 days. Okay, and then click on OK, step by year. Click on OK. 200 new dates have been added, of course. Click on OK. Okay, so if you go down, we will move per year until we have here 2223. Okay, and set stop, we will check it here. So the simulation will stop here. Okay, so the simulator knows to stop at this date. Click on close. All right, and then let's right click on wells and then click on new. Okay, so we will add a new injector, and let's call our injector CO2 underscore injector, like this. Okay, and be sure to choose injector as the type. So click on type and then injector. Okay, and the well should be defined at here 2023 January 1st. Okay, and from here, yeah, no need to define the group. It's only a single well, by the way. So let's move to constraints. Okay, and in this tab, in this window, check the box for constraint definition here. Okay, and we will have two constraints. The first one, click on this one. Okay, let's select operate. And for the operate, for the parameter, let's select surface gas rate, STG. The maximum to be only 10,000 meter cube per day. And let's select count repeat. Okay, easy. And then select new again. And here we will select operate, but now it's bottom hole pressure. Okay, so the maximum bottom hole pressure will be 4.45 e to the power of 4. Okay, and again, it's also continued count repeat. Okay, so make sure you have operate, surface gas rate, and bottom hole pressure maximum 10,000 meter cube per day and 44,500 kilopascal. Both of them are continued repeat. And yeah, everything is okay down there. No need to use multiply at this stage. Well bore, no need, and then injected fluid. Okay, so here we will inject CO2, by the way. So not water, but instead we select solvent. Okay, we select solvent and then specify the mole fraction. Of course, it will be pure CO2. So 1, and the summation will be 1. Okay, so click on OK. So we already have the well, but we still don't know, and we still haven't defined the location. Okay, so now the location and perforation interval for the injector needs to be defined. Okay, you make sure you are in two-dimensional view, so because it will be easier for us to locate the well and the perforation. So let's select IK 2D view, yeah, and in the tree view expand wells, okay, and then injector, okay, and then double click on the perf. All right, can we expand this? All right, okay, and then let's go forward to the perforation tab and let's add perforations. Okay, we can do it manually, by the way, by clicking on this one, add perfs with the mouse, but I don't want to do that. Instead, I will select this one, insert before selected nodes. And then, okay, I need to input it first. So 1, 1, and 18. So it means for grid I, it is located at I equals to 1, j equals to 1, and k equals to 18. So that's the first perforation that I have. Okay. By the way, j will always be 1 because we only have one j layer. And this will connect to surface. And status is open. Okay. And okay. So well index 0, form factor 1. Okay. So yeah, everything is like this. And then like this. 1119 right now, and connect to 1, of course. And lastly, there, 120, connect to 2. It's, by the way, a vertical well. Direction k-axis, status open. Okay, so it's like that. Click on apply and click on OK. So you see, if you maximize, you can see CO2 injector there, and your perforation is located down there. Okay. K11, K19, I mean K18, K19, and K20. I equals to 1 and J equals to 1. Okay? All right. So I think so far so good. And so let's make it. Okay, like this. So this exercise, we built this exercise around the trapping mechanism of CO2. So the trapping mechanism of CO2 will be very, very important in this exercise. As I said before, first we will, in the base case, we will consider only structural trapping, but subsequently we will add hysteresis trapping or residual trapping, and then, solubility trapping and mineral trapping. Okay, but the important thing here that we need to note is actually because it is a two-dimensional model and it is the migration and trapping of CO2 that is of interest, the injector is to be shut in after 1 year of injection. Okay, so yeah, I think you need to know the basic of CO2 sequestration. And yeah, of course, the CO2 injection is not forever. Okay, maybe you will do injection in 1 year, or maybe 10 years, or maybe 15 years, 20 years. But after you complete the period of injection, you will shut your well in. Okay, you will shut in your well, and then you just monitor using seismic, logging, and others. Okay, so but in this simulation exercise, I will do the injection only for 1 year. And after 1 year, I will shut my well. Okay, I will shut in my well. Okay, so of course we will do some modification in the well setting. And let's go to the events. Yeah, okay. After you double click on the well in the tree view to open the well events, under the option, yeah, okay, options, check the status as shut in. Okay, of course, we will locate it at 2024. Okay, so only 1 year after injection, after 365 days. Let's go to options and status. It's no longer open, but instead, okay, click on status and then let's change it to shut in. So 2024, January 1st, the well will be shut in, and all the subsequent dates after this date will also be considered the well to be shut in. Okay, make sure to not click anywhere except on the options tab after selecting the new date. Okay, maintain all the settings except the status, especially make the status to be shut in. Okay, so yeah, I think that's pretty much it. Click on OK. So you see we have obtained all the green checks there. Okay, but yeah, we can also add more outputs because it is of our interest. Over the next few exercise, yeah, there are a number of concepts to be investigated and understood. And yeah, I mean is about solubility trapping, hysteresis trapping, residual trapping, mineral trapping. Okay, so there will be a number of concepts to be investigated and understood in the future. And for this, some extra properties need to be looked at in the results. And output recording for these extra outputs should be turned on. Okay, so to enable more results that is of our interest, we need to go to IO control, click on that, and then simulation results output. Okay, we can generate many results. Not all of them are necessary, but because it is CO2 sequestration topic, there are results that are of our interest. And in general case, in base case, non-CCUS, those results will not be, you know, will not be generated to save calculation time. But we want them. We want those results. That's why we want to change the settings so that those results will be produced. Okay, so you see here frequency of simulation results file writing, when to write, WSRF, the keyword, initial well grid, specified frequency, every time or that keywords. Okay, so initial well specified frequency, good, value 1, initial grid every time or date keywords, okay, good, and items in simulation results file, what to write. Okay, so this is that this is the one that we want to check. Okay, initial grid, select grid variables, click on select, and initial reservoir, no variables. Okay, so click on select here. Okay, you see there are many keywords there. Okay, that are associated with a certain results. Okay, like this, press. It's associated with pressure. That's the base keywords. Gas saturation. So you will always obtain results about gas saturation and pressure. But you can also produce other results like shear modulus and radial shear stress. But of course, producing them in all cases will be unnecessary, will be inefficient. It will take more time for the simulator to produce. It will take more calculation time. Okay, so that's why in base case setting there will not be check. Okay, so there are parameters that we want to check. First, deselect all. Okay, deselect all, and then let's start selecting the parameters that we are interested in. So the first one is gas mass density. Check that one. And then water mass density, then W. And then porosity change due to mineral reactions. Later in mineral trapping, this result will be useful. Okay, so porosity change due to mineral reaction, D4 MNR. And then gas relative permeability, of course, KRG. So you see, you can follow the keywords. They are arranged following the alphabetic approach, right? So KRG and then KRW, good, water relative permeability, and then molality of CO2. Molality of CO2, okay, it's like molarity, but it will be based on the mass, okay, of the mixture. So it's component molality in aqueous phase of CO2. And then permeability in H direction, of course. Let's find perm. And then pH value, and then porous, current porosity. And then press for the pressure. And then SG for the gas saturation. And then SG DTHY, dynamic trapped gas saturation for KRG hysteresis. It's a lengthy word, but yeah, indeed, it's very interesting and important. Dynamic trapped gas saturation for KRG hysteresis. By the way, it's not a promotion, but CMG regarding CCUS and also for enhanced oil recovery, they are very, very good. Okay. You can see from these keywords and the variable description, you can understand that CMG is doing a very good job. And then gas saturation for KRG hysteresis and residual gas saturation for KRG hysteresis. So these three are about hysteresis trapping. Okay, hysteresis trapping is residual trapping. That's the other name. So the CO2 will be left immobile in the pores. Okay, and it will not be kicked out of the pores, and there will be there permanently. But we need to know in more detail about the dynamic trapped gas saturation and the gas saturation and the residual gas saturation. Okay, so we need to make distinction: dynamic trapped gas saturation itself, and residual gas saturation. And then water saturation, SW, of course. And let's see, water viscosity, VSW. All right. And then mole fraction of CO2 in aqueous phase. Mole fraction of CO2 in aqueous phase. Of course, it's about solubility trapping. And then global mole fraction of CO2, ZCO2, and mole fraction of CO2 in gas phase, YCO2. There. Okay, it's very good. Click on OK. All right. And then yeah, select grid variables, right? And then let's click on this to activate the output for well-related parameters. Okay, so select this date, select new date and type, this one. And for this one is grid, well. Okay, note input output after the date time string indicates there are input output control keywords on these dates. Okay, click on OK. All right. Okay, so initial well, select well special variables, select, and choose layer all downhole. Let's see. Let's expand this. Or maybe close. Select this one first. Okay. Layer all downhole. Well values for all layers at reservoir and surface condition. Select this one. Okay. And for the reservoir, let's select all. So it's like this. Okay. And add another well row. Let's click on this one and then click on well. Okay. And special variables. Expand this. And let's check several parameters, several keywords. So greenhouse gas, EQ, this one, and then liquid, and then mineral, and then critical, CO2, supercritical fluid, and then CO2 soluble in aqueous phase, GAG sol, and then trap, total trap. Okay, that's very good for the result. Okay, click on OK. All right. So let's check the simulation results file writing. Okay, should look as follows, like this. Initial well specified frequency 1. Initial grid every time or dates keywords. Okay. Initial grid select variables. Okay, we already did that in select. And then initial reservoir no variables. Should be all, by the way. Okay. And then for the initial well values for all layers at reservoir and surface condition. Okay. And initial, oh, it should be, yeah, it should be well. Or maybe, sorry, we can add, and it's actually spatial. Okay. And then let's do the same thing. So we will get this result from special section in result. Later on, I will show you. So it will not be shown under well result, but it will be shown under special result to make a distinction so that we can notice it earlier. I mean easier. Okay, so check this. Click on OK. Okay, and click on OK. Good. And then let's save. Okay, and later after this we will end this here using the builder, but later we will go to the dataset and we will open the dataset in text editor and we will insert another keyword. It's inventory CO2. Okay, and yeah, later I will show you. We will modify the dataset in text editor. Okay, so I think we can call it a day. Thank you so much for watching. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next Eng-Man videos. Thank you.